Okay, just setting up a grid, okay? Whilst I'm doing this, what kind of sampling do you think we're going to be doing if I'm setting up a grid? We're going to do quadrats, yeah, but think about different types of sampling techniques and what they might be. It was in plain one. What types of sampling do you know? Say again? Random sampling. So that's one type of sampling. What other type of sampling can we have? What did we do yesterday? Think about how we did it. I didn't mention it yesterday, but think about how it was set up yesterday for our data collection.
Distance, wasn't
it was
like certain distance.
It was certain distance, yeah. So if we've got certain distance, it's not stratified, systematic, yeah. So yesterday we did systematic sampling. There was a set distance along a transect that you were working, okay. Your other is random. Today we're going to do random, okay. So setting out this grid, okay. It's a 10 by 10 grid, okay. We're going to split into 4 groups in a minute, alright? Each group will need a jazzy bag, which has got some kind of pattern on, alright? And a plain bag, okay? You'll need one of each of the bags for each of the groups, okay? In those bags, the first thing that you need is your recording sheet, okay? So on here is everything that you're going to need, that you're going to be recording, okay, in this area. So we're on our moorland area. What observations can you make about this area before we do any kind of data collection? What do you notice? Go on. It's
where you stood. Where you stood.
Where we are here, is there any trees? No. So there's no trees, so it's deforested, or it might not have been forested in the first place. Okay. How would you describe it? What else can you say about it? Go on.
Barren.
Yeah.
Short.
Short bushes. Do you know what type of the main type of plant is that's grown here?
Heather.
Heather, yeah, excellent, okay. Although it doesn't look it now, in its form and glory, it's nice and purple, okay, and it's covered over this whole area, okay. Can you remember from your maps last night what the rock type is, if you dig down here? We're on the North York Moors. Yeah, excellent, yeah, sandstone. So if you were to dig down here, it's sandstone, okay. What was the ground like as you were walking across it? Squidgy. What is this soil type underneath here? It is quite saturated. It's a specific type of soil. It's yeah, good, peat, yeah. So it's sort of peaty soils, really saturated. Peat soils, what do you know about peat soils?
Very preserving.
Yeah, very preserving, yeah. Good, what else? Hold a lot of water, yeah. So if you think about our carbon cycle and our water cycle, hold a lot of water, so they're quite wet, quite damp. What about carbon?
A lot of carbon in it.
Yeah, carbon rich. If you think it's really dark, really black, okay, really carbon rich, okay. So we're looking at this area, we're going to compare our moorland area to our afforested, which is just over on the other side there of those trees, okay. Right, there's a number of things that you're going to measure, okay. What you need to do, alright, is you need to get a random numbers table, okay. Each group is going to have a different letter, alright, and we have set up a 10 by 10 grid, so you're looking at this table in the middle, okay. So it's totally random where you're going to sample, okay. What's good about random sampling?
It's usually quite like representative.
Yeah, when would you do random sampling? What's the area like? What's the area like?
Large area, so that you don't have time to do all of
Yeah, perfect. So you're not going to have time to do the whole area, okay? Why can we use random rather than a system or stratified? What do we know about this area? It's what? It's all moorland, yeah, it's all the same. It's all the same area. So we are assuming it's all the same. It's called a homogeneous environment, okay? So it's all the same area, it's a homogeneous environment. So we can pick an area and we can random sample that area because we expect that if we go over there, it's going to be exactly the same. If we go over there, it's going to be exactly the same. So it doesn't matter where we're going. If it wasn't the same, you would do either stratified or you would do systematic, depending on what the area was like and if you could work out proportions of the area and things. Okay, so that's why we're doing our random sampling. Alright, select your, each group is going to have this letter, and then you're going to select your coordinates. So for example here it says 0, 3, so I'm just picking the first one for A. Okay, so it's just like a graph. Okay, along 0, up 3. Okay, so you're going to start at 0, go up 3 meters. You can have people that can walk to meet in that location. Okay, I'm just going to do it here just to demonstrate. Can I take a quadrat, please? Thank you. Alright, you're going to place your quadrat down in that location. Your bottom left corner, alright, is going to go in that location. Okay, so wherever it lands, wherever it meets, that bottom left corner is going to go in that location. Okay, the first thing you're going to measure is soil moisture. Okay, you have got one of these. This is a soil moisture meter. Okay, I'm going to switch that on. Okay, this reads in percentages. Okay, how many soil moisture do you think we need to take?
3.
3. Why do you say 3?
Just like you got you can work out averages.
Yeah, excellent. So at least 3 to get an average. We're going to do 4. Okay, we're going to do 4 soil moistures. We're going to stick it in the ground. What do you think we need to think about when we're putting this in the ground? Yeah, how far you put it down. We want a standard set. Okay, so about 10 centimetres. Okay, down. The way that this works is you have to read it upside down. So if you go like this and read it upside down, okay, that is reading 8.3%. Okay, so it's got a point in the middle, so don't get confused. It's not 83. Okay, it's reading 8.3%. Okay, take that out and then do it in each of the 4 corners. Okay, so that's reading 12.6. Okay, so you just do each of the corners and record it 4 times and then work out a mean. Okay, you're going to do at least 3 quadrats. All right, if we can do 5, that's going to be perfect. All right, but you're going to do at least 3 quadrats. Okay, you also need to know the humidity of that area. You've all used one of these before. All right, nice hygrometer. Okay, again, percentage. Leave it in the middle of your quadrat, let it acclimatise a little bit, okay, and then you're going to just take 1 humidity reading. Okay, so leave it to acclimatise. You might want to do your other things while you've left it out to acclimatise, then go back and take your humidity. Okay, you then want to take a percentage of bare ground. Okay, so by bare ground, any soil that's visible, anything like that, you're going to work out percentage. Okay, how much percentage do you think? James, come and have a look at this and tell me how much percentage you think there is of bare ground in that quadrat.
A little bit there. Like
Yeah.
10% maybe. 20.
Okay, James is going for 10. Wendy, come and have a look at this.
3.
So in here, how much bare ground can you see as a percentage? You're going for 10 as well?
15.
Okay. What's my name? Emily, come and have a look. What are you going for? 15. Emma's going for 15. Remind me of your name.
Charles.
Charles, come and have a look.
Yeah, but
You're going the same. You're not wavering off there.
I'm fine with the 20.
All right, 20%. Okay. Thinking about that method, what's an issue with that method?
Just
Yeah. So what's it called? It's an S word. If you're deciding, it's very subjective. Yeah, excellent. Okay, so it's a subjective method. All right, you're having a look and deciding. These little bits of red tape, okay, they are marked. All right, this is a 50 by 50, so they're marked every 10. Okay, so 10, 20, 30, 40, and then 50. All right, so that area there, all right, is 4%. Okay, does that make sense? Or if you have it along that line, that's 10%. So that little line there that goes all the way down there. Because if you imagine this, what's the other type of quadrat you could use? What's another type of quadrat you could use?
One with those little squares.
One with the little squares in, yeah. Do you know what that's called? It's called a gridded quadrat. So it would have all of the lines in here, okay, going across, and there'd be 100 squares in that quadrat, and then you could work it out by what's in the square, okay? So as a group you need to work out, I think there is quite a lot of bare ground there. Alright, that to me is at least, I would go at least 40-45%. Okay, because all of this area here, underneath the grass, all down here is all bare. Okay, so it's quite a lot of bare ground. You need to think about it in 3D layers. Okay, so there's things underneath other plants. Okay, so you need to have a look underneath. Alright, so as a team, you're going to decide what your percentage of your bare ground is. Okay, you're then going to look at the different vegetation species. Okay, so in your bags, we've got some keys for you. Okay, so there's some woodland plants on there. Alright, we've got some moorland plants on there. We've got some mosses and lichens on there, because you might find some mosses hiding around underneath as well. Okay, so you're going to have a little look and ID them. There's also, this is called a Dichomous Key, so it's a set of questions. So if you're struggling to ID it, follow the questions down. So one for alright. So you're going to work out what it is. Okay, so you're going to say, right, this here is heather. I know that this is heather. Alright, and then you're going to work out again what percentage cover there is of heather. Okay, so how much heather is there, how much grass is there. Okay, have a look underneath to see if there's any mosses or anything hiding underneath. Okay, and work out your percentages. Your vegetation species and your bare ground need to be at least 100%. Okay, but they can be more than 100%. They can't be less than 100%, but they can be more, because you could have 50% of grass, and then hiding underneath you might have 60% of moss, and then you might have 30% of bare ground. Okay, so you can have over 100%, but you can't have under. Okay, so you need to make sure that your vegetation species and the bare ground add up to at least 100, but if it's over, that's fine, because you're thinking of it in your 3D layers. Okay, does that make sense? Yeah, so you're going to do that in at least 3 quadrats, okay, using your random numbers. Yeah? Any questions so far? Okay. The other thing we're going to do, what was the other thing that we were going to measure? Water cycle? Wendy? Infiltration. Excellent. Okay, so we're going to measure infiltration. We're only going to do this twice. Okay, so we're going to do it at your first quadrat and at your third quadrat. Okay, because it takes a little bit of time to do it. Okay, what you need to do. Okay, all sorts of fancy kit in here. Right. You are going to do this in the middle of your quadrat. Okay, so you might need to move some vegetation out of the way. Okay, rip some vegetation up, move it out of the way. Okay, and these are Cranedale Centre made infiltrometers. Okay, we've got a set distance that we know how much is here and how much water we can hold in this. Okay, you're going to bash this into the ground up to the bottom white line. Okay. So you're going to pop that, it needs to be nice and straight and nice and flat, okay, not at an angle, alright? You're going to have one person holding the wood on the top, you don't hit directly onto the infiltrometer, okay? And the other person, alright, is going to bash that into the ground, okay? Nice and straight. Until you look in and you can see that the soil is at the bottom of the white line. Okay, so that's going all the way into the bottom of the white line. All right. What you're then going to do is you've got a set amount of water in each of these. Okay, and you're going to time how long it takes. Where did I just put that? Stopwatch. I'll find it. There is a stopwatch in your bags. Put it somewhere, and you're going to time how long it takes. Okay, what you do is you take the lid off here and you tip it upside down all in one go, as quick as you can. Get that into there. As soon as that water, all of the water has gone in, you press the start button. Okay, you're then going to time how long it takes for that water to go into the ground, how long it's going to take to infiltrate. Okay, now it might be that it takes longer than 5 minutes. If your stopwatch gets to 5 minutes, stop what you're doing. Okay, if it takes longer than 5 minutes, you're then going to measure the distance of how much is left in your infiltrometer. So you're going to measure down from the top of the water level to the top of the infiltrometer. So it might be 5 centimetres, okay? You're going to measure how much is left. Does that make sense?
Is that how much water's left? How much is empty?
How much is the distances from the water to the top. So it's like how much is infiltrated. So that'll give you an indication of how much water is infiltrated into the ground.
And when you're hammering the infiltrometer down, how far does it go down again?
To the bottom of the white, there's some white tape.
Right, so the bottom of that, right, yeah.
Yeah, so the bottom of there, all right? It needs to be soil, okay? So you need to make sure that you get down, move the plants out of the way and it gets down to soil so that you can bash it in and then you tip it in, okay? If it takes less than 5 minutes, then you just write how long it's taken, okay? What you then need to do, all right, is you need to take your infiltrometer out, okay? And you put in there your infiltration time. So if it's less than 5 minutes, then you can put your time. If it's 5 minutes and you've stopped there, you still write 5 minutes. You then write how much water is infiltrated in centimetres, okay? If it's completely infiltrated, that's 13 centimetres of water, okay? If it's not all infiltrated, then you've measured how much is left so you can work out how much has infiltrated, okay, into the ground, okay? You then work out your infiltration rate, which is your centimetres per hour, okay? So it's your water infiltrated, so that's your M, divided by your time, which is your seconds, okay, that's measured in seconds, all right, times by 3,600, okay, and you put that into there, all right? You also need to do a colour smear, okay? So once you've taken your infiltrometer out, that ground will be nice and wet for you, okay? So it's nice and easy. Get a bit of colour smear and you just smear it onto your page, okay, to see what colour it is. How's that going to affect our results and what we're looking at and what we're thinking about? How do you think that's going to be different?
Did it-
Possibly, yeah. What other predictions might we make? What did we say about this soil here? Carbon, and it's very dark, yeah. So we might expect that if there's more carbon, it's going to be darker soil. Okay, so you might think that as well. Okay, you might think the wetter it is, the darker it is. Okay, so we're going to put on a colour smear there as well. So you're only going to do that twice. So your first and your third one. Okay, does that make sense? Yeah. Everybody happy with what they're doing? Anybody got any questions? Okay, you're all going to work together in this 10 by 10. Okay, so if you get yourself into 4 groups, okay, so I think it's 3 4s and a 3. Is that right? 3 4s and a 3.
Make sure you've got a
Make sure you've got a jazzy bag and a plain bag.